This is Chapter 3, Lesson 1, Constant Rate of Change. Okay. So when we're talking about constant rate of change, a blank, blank, blank is a rate that describes how one quantity changes in relation to another. So in those first three blanks, you're going to write rate of change. Okay. So a rate of change is a rate that describes how one quantity changes in relation to another. In a blank blank, the rate of change between any two quantities is the same. So in a linear relationship, so linear, L-I-N-E-A-R, linear relationship, the rate of change between any two quantities is the same. So basically a linear relationship means it graphs a straight line, okay? A linear relationship has a blank, 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 blank. You're gonna write constant rate of change. So a constant rate of change. A linear relationship has a constant rate of change. So basically this idea is that the change over time is going to be constant. It's going to stay the same. That's the idea for constant rate of change, okay? So there's actually a couple different strategies. You can use a table or you can use a graph. Both work well to show constant rate of change, okay? So let's look at strategy 1, use a table. Okay. The table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So remember last time when we were setting up proportions, you're going to do kind of the same thing. You find the unit rate to determine the constant rate of change. So in order to do that, I'm going to take the first one here where it says 5 for the number, $40 for money. So they washed 5 cars and they made $40. Okay, in order to figure out the unit rate, recall way back from lesson 1 that unit rates have to have a denominator of 1. Okay, so I'm going to take $40 because that's the money that they made for washing 5 cars. So 40 divided by 5, which gives me $8 for 1 car. So the number of dollars earned increases by $8 for every car washed. You can go and double check this by multiplying the number by 8. It should give you the amount of money that they earned. The second strategy is using a graph. So the graph for the same exact type of equation, okay? The graph represents the number of t-shirts sold at a band concert. Use the graph to find the constant rate of change in numbers per hour, okay? Now, in order to find this rate of change, I'm going to look at my graph. The graph has time as the x on the x-axis and t-shirts on the y-axis. Now, at 8 p.m., so here's 8 p.m. At 8 p.m., they had sold 25 t-shirts. Okay, so that's important to know. At 9 p.m., they had sold 30 t-shirts. And at 10 p.m., they had sold 35 t-shirts. So you can see just by looking at it that I go from 8 to 9. I went from 25 to 30. That's an increase of 5. Going from 9 to 10, that's an increase, again, of 5. So my constant rate of change is probably going to be 5, but we can double check and make sure. To find the rate of change, I pick any 2 points on the line. So let's say I picked 8, 25, and 10, 35. Okay. Then I set it up. Change in number, so the change in number, 35 over 25, so your y values, your change in number, 35 minus 25, over your change in time. So how long did it take? From 10 to 8, that's 2 hours. So 35 minus 25 gives me 10, and 10 minus 8 gives me 2. So 10 divided by 2 gives me 5. That tells me there's 5 t-shirts per hour. So that's my constant rate of change. Okay. So now you do the 2 problems at the bottom of the page. Try it out. Go ahead and pause the video. And when you're done, come back and we'll go over the problems together. All right, now that you've tried the problems yourself, let's look at them and try to solve them together. The first problem says the table shows the number of miles a plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. So we can see I have minutes to miles, 30 to 290, 60 to 580, 90 to 870, and 120 to 1,160. So they gave us a table, so we're going to use the strategy use a table. And I'm going to pick any 2 numbers. Doesn't matter which numbers you choose. I'm going to go with the first one. Okay? So I'm going to come over here. And I'm going to set it up. Distance over time. Okay, because usually it's your y value, your distance in t-tables or in charts like this. Your second value is usually your y value. That's usually the one that goes on, that's usually your numerator. Okay. So I have distance over time. So the distance I chose was 290 over my time, which was 30 minutes. And now I'm going to divide. When I divide 290 by 30, I get 9.6. Okay. You can do the math to double check. You can notice that they both have a 0 here on the ends, so it just cancels itself out. So now I have 3 and 29, so 29 divided by 3. 3 goes into 29. 9 times, that's 27. When I subtract, I get 2. So I'm going to add a 0.0 and bring it down. 3 goes into 20 6 times, which gives me 18. And then it's just going to repeat over and over again. So get 9.6 repeating. Okay. And they did tell me approximately, so 9.6 I can round up. And we use the squiggly equal sign. That means that it's approximately 10. Okay, so it's approximately 10 miles per minute. That's my approximate constant rate of change. You really want to make sure that you include your units with everything that you do to make sure that you've got the correct answer. Now, the second problem that they give us states the graph represents the distance traveled. Use the graph to find the constant rate of change in miles per time. Okay, so I can pick any 2 points that I would like to pick. So I have 10, 72. So I have 10, 72 I can choose from. 1280. Okay, and then I go to 2. So you actually want to think about this a little bit. The way our clocks are actually set up, it allows us to go to 24-hour periods. So 12 is still 12. 1 o'clock, 1 p.m. would be 13. And 2 p.m., which is right here, would be 14. So that could be another point. I could have 1488. I'm going to go ahead and use 1488 and 1280. You don't have to use these 2 points. You'll still get the same answer. Okay. So now I'm going to go set up my equation. So I have change in number, which was my 88 minus 80, and then change in time. Okay, and that was 14 minus 12. So 88 minus 80 gives me 8. 14 minus 12 gives me 2. 8 divided by 2 gives me 4. So this tells me that my constant rate of change, according to the graph, is 4 miles, because that's the time, or that's the distance that it's measured in, to time. Now notice my time's in hours, so I'm going to put hours. Miles per hour. Okay? And that is the end.